Nathan from Civil Department, SVC Bangalore. I would like to tell about the influence of soil texture and the environmental conditions on frozen soil and infiltration. Introduction. Several processes occur simultaneously in a freezing soil, such as phase change of water with associated latent heat flux, capillary and gravitational flow, conduction of heat to the solid and liquid soil constituent, and increases in metric potential of frozen soil, volume resulting in the distribution of unforging water. Given the complex interaction of these processes, it is hard to predict how soil properties and environmental parameters, for example air temperature and initial soil moisture state, affect foraging soil infiltration capacity. Laboratory and field testing would be demanding in view of many possible values of process parameters, further complicated by the difficulty of measuring ice and enforcing water content in soils. The gain of most experimental studies, therefore, mostly qualitative rather than the quantitative understanding, despite providing useful measurements of insights. In this, the study we existing the single domain numerical code to stimulate the freezing and thawing of variably saturated foraging soil columns in combination with infiltration of melt and rainwater. First, we assessed whether the numerical code, which has previously been tested for freezing soil column experiments, could satisfactorily reproduce the full freeze the temperature cycle of a laboratory soil column experiment as well as the infiltration pattern in the foraging soil. Subsequently, we performed a series of numerical one-day tests simultaneously to investigate the controlling factors on infiltration capacity of foraging soil, such as initial saturation, temperature, boundary conditions, and soil parameters. The results gave insight into the theoretical link between soil freezing and infiltration reduction, and the role soil and environmental parameters play. Herein, the focus lies on the soil matrix flow with the texture, ranging from the course of very fine are examined and environmental conditions are chosen to encompass wide range of possible field situations. Methods of numerical model. In this study of employed the semi-empirical version of a numerical model that is described is detailed by it is one-dimensional water and heat transport model that includes the phase changes between water and ice. We choose the semi-empirical version as it requires the least amount of parameters to stimulate freezing. The energy exchange boundary between the soil and snow of atmosphere was simplified by a fixed temperature boundary of the top of water flow and based on the Richards, while heat transport was being governed by the energy balance equation by includes thermal induction and reduction of latent heat transfer. The numerical model has previously been tested on the experimental data sets of freezing in columns to the test of ability of model to stimulate the thermodynamic thawing process as well as compare the result of the model and full freeze thaw cycle experimentally by in 2017 in which soil of temperature was measured different depth in experiments. A 20 cm column with silt soil of initial temperature of 1 degree was periodically frozen and thawed from the top. The side walls are insulated by the bottom temperature was kept at a constant temperature at 1 degree freezing and thawing periods such as lasted 24 hours with temperature as 5 and 5 degrees Celsius imposed to top of the soil column. This was repeated until 6 days. The grain size functions of soil were reported in the original study, but the water restriction tension parameters of hydraulic conductivity, therefore, such as Rosette Bell transfer function in present sand soil texture classification triangle. A dark gray areas are soil simulated in this study, with the number of referring by soil numbers of large red lines distinguished between coarse intermediate and very fine soils. The organic layer is placed in the area commonly classified as silt clear loam because the organic layer has very similar water retention capacity compared to the soil type. The intersection of a reference of color in the figure legend or reader is referred to the web version of the article. All combination of conduction is were tested each soil type, the except from the input water input temperature which initially varied in the simulations, but during testing we found it had to be noticeable effect. The limit computational time therefore only tested input water of soils 1, 2, 3, 4.6 soil parameters used in the different solutions. Sand, loamy sand, sand loam, sandy clay loam, silt, organic layer, silty. The ice saturation. It is apparent that soils with intermediate textures at the highest ice saturation are freezing phase. Looking at all cases combined in the box plots, this concerns medians, upper quartiles and outer layers. These are the only soils which have cased in over 25% of the entire column saturated with ice in the computation where the coastal soil 1 and 2 never had more than the about 14% ice and ice saturation of the column with the very fine textured soils 7 and 8 we observed the lowest median observation of the 3% respectively. Nevertheless, these soils and outer layer cases in which saturation exceeded 15%. More, it was notable that the lowest value of ice saturation is higher of the core soils and 1 and 2 of 4%, while it was approximately 0% for the other soils. Lastly, we observed that the variability of ice saturation was highest for the intermediate soils. So this is about the introduction of the texture, the environmental conditions, and the frozen soil filtration.